We've been using dimensional analysis to help us solve some problems. These next couple involve a little extra because they involve area and not just a single dimension. The first one says we're tiling a floor 10 by 10 and we know that 100 tiles will be needed. How many tiles would be needed if we want to tile a floor that's 20 by 20? Well, we know that area is equal to length times width, so a 10 by 10 room is 100 square feet. So our ratio is going to be 100 square feet and 100 tiles. So I'll use that however I need in the problem. What we're going for is a 20 by 20 room. So the 20 by 20 is going to be 400 square feet. So we'll start with our 400 square feet and we'll multiply by our ratio of 100 tiles over 100 square feet. Now in this case, because they're both 100, it really wouldn't have mattered if we goofed them up. But remember, the important thing is that the labels cancel and what's left is what you really want. So the square feet cancel and we are left with tiles. So we did set it up correctly. And our answer for this one would be 400 tiles. Now let's make it a little more complicated. Suppose we shop around and we find a 6-inch by 24-inch tile that we would prefer to use instead of those square ones. And we know that each tile is $1.49. How much will we spend on the tile? Well, it probably would be important to figure out how many square feet are in this original tile that we're going to use so that we can figure out how many tiles we're dealing with. So what we could do here is say, all right, one tile, it's 6 inches by 24 inches, but I'm going to convert the inches into feet by 1 over 12, 1 foot to 12 inches, the 24 inches into feet, 1 foot over 12 inches, multiply across the top, and I'll get square feet, multiply across the bottom, and it will cancel with the labels that are up there. So my answer is square feet. And it turns out it's 1 square foot. Kind of fun. All right, so let me get rid of this down here, and we'll take a look at the rest of the problem. So we know we have 400 square feet to work with. We know that one tile is 1 square foot, so my square feet cancel. I also know that it's $1.49 per one tile, so the tiles cancel. So the square feet cancel, the tiles canceled, only thing left is dollars. So my final answer here is the answer I'm looking for, 596. Let's take a look at another one, similar but with circles. So a 12-inch pizza requires 10 ounces of dough. How much dough is needed for a 16-inch pizza? I have to keep in mind I'm looking at the area here, not just a single dimension of 12 inches. So for circles, we remind ourselves that the area is pi times r squared, where r is the radius, and the radius is the same as half of the diameter. Okay, because that's important because they gave me the diameter, not the radius of this pizza. So my 12-inch pizza, the radius would be half of that, or 6. So the area is pi times 6 squared, or 36 pi. For the 16-inch pizza, the area is going to be pi times 8 squared, or 64 pi. So now I can actually use this requirement, or not requirement, the ratio. 12-inch pizza, or 36 pi area, requires 10 ounces of dough to figure out how much dough is required for the 64 pi. 64 pi square inches times the 10 ounces for the 36 pi square inches cancel, pi's cancel, we work it out, and it looks like we're going to need about 17.8 ounces of dough for this pizza.